Alright, in this section we're going to expand on what we did in the previous section. We're going to apply our rules for multiplying and dividing fractions to mixed numbers. Now in this section, we're not only going to be talking about finding the exact answer when multiplying and dividing mixed numbers, we're also going to look at estimating. So before we talk about estimating, let's talk about rounding mixed numbers. Now, we talked about rounding whole numbers in the past. And so let's look at a quick example of that. Let's say we are looking at 37 and I want to round to the nearest 10. So remember that when we talk about rounding, we look at the number directly to the right. We round up if 5 or more, and we round down if less than 5. So for instance, this one's going to round up to 40. So 5 is the magic number. And so what is special about 5? Well, 5 is the halfway point. And so basically, if it's half or more, then we round up, and if it's less than half, we round down. We're going to apply that to fractions. So, what's our rule for rounding mixed numbers? If the fraction part is half or more, we're going to round up. In order to do this, we add 1 to the whole number. If less than half, we round down, and remember when we round down we leave the whole number as is. Now when working with whole numbers we replaced all the digits to the right with zeros. For instance, over here we replaced the 7 with a 0. When we talk about rounding mixed numbers, the last thing we want to do is discard the fraction. Remember that the whole purpose of this is we're going to talk about estimating. We want to make the problem as easy as possible. That means getting rid of the fractions. So let's go ahead and look at some examples. Now when I look at fractions, think about having candy that you're splitting candy with between you and your friend. If you have at least half or the majority of the candy, we're going to round up. We're happy. If we have less than half the candy, we are not happy, so we are going to round down. So for instance, 2 3/4. If I have 3 out of 4 of the pieces of candy, do I have at least half? The answer is yes. So in this case, I do want to round up. We're going to change the 2 to a 3. We add 1 to the whole number, and we discard the fraction, so we leave our answer as 3. Example B, 6 3/8. If I have 3 out of 8 pieces of candy, then my friend has 5 and they have more than I do, which means that I'm not happy. So this is one where we want to round down. Remember, when we round down, we leave the whole number the same, and we discard the fraction. 1 5/8. If I have 5 out of 8 pieces of candy, that means my friend has 3, so I have more. So that means that I am happy. We are going to round up, so I'm going to make the 1 a 2. And we drop the fraction. Now for some of these that have an even number, those ones you might find relatively easy. Now when we talk about having an odd number in the denominator, you might struggle a little bit more with those. So that's where we want to keep in mind how much do I have and how much does my friend have. So if we look at 3 2/5, if I have 2 out of 5 pieces of candy, my friend has 3. They have more than I do. So this is less than half. We're going to round down, so I'm going to leave my whole number the same. and drop my fraction. 4 2/3. If I have 2 out of 3 pieces of candy, I have more than my friend who has 1. So I'm happy. I'm going to round up. 4 becomes a 5. And we drop our fraction. Okay, what about 7/11? If I have 7 pieces of candy, my friend is going to have 4. I have more than they do. So I'm going to round up. This is going to become a 2, 1. We're going to add 1 onto 1, and we drop the fraction. Now what about 3 1/2? Well, if I have 1 out of 2 pieces of candy, I do have at least half, so I can't complain. So this is the one, this is the exact middle, and remember, if it's in the middle, we round up. So this means that I'm going to add 1 onto the 3. It becomes a 4, and we drop our fraction. What about 5 4/9? If I have 4 out of 9 pieces of candy, my friend has 5, so I'm not happy. I'm going to round down. So I'm going to leave my whole number the same and drop my fraction. Okay, so we're going to use this when we get into estimating. And remember that estimating means we round and then we perform the operation. So we'll see this again shortly. Okay, so procedure for estimating an answer. We want to round the numbers and then perform the operation. When we are done with our problem, we want to go back and check that our answer, our exact answer, is close to our estimated answer. The other thing we're going to do is we're going to find the exact answer. So our procedure for multiplying and dividing mixed numbers. The first thing that we need to do is we need to convert the mixed numbers into improper fractions. Once they are in fraction form, we can perform our operations. Remember that multiply, we cancel common factors and we multiply straight across. And for division, we copy dot flip. Once we have our final answer, we want to convert it back into a mixed number, if possible. All right, so let's go ahead and look at some examples. We'll start with multiplication. First thing we want to do is estimate the answer and then find the exact answer. And remember that when we do this, we want to always write our answer as a mixed number. Make sure you remember in lowest terms. All right, so let's start with example A. I'm going to start with my estimate. So 2 1/2, do I round up or down? Since 1/2 is half or more, we do round up, so this is going to become a 3. 7 1/3. 1/3 is less than 1/2. So I round down. I'm going to leave the 7 as it is and drop my fraction. We can multiply this now. 3 times 7 is 21. That's my estimate. All right, so let's go ahead and find our exact answer. First thing I want to do is convert to improper. So remember, this is kind of our around the world thing. We're going to multiply 2 times 2, which is 4, and add 1. We get 5 for our numerator over, keep the denominator the same. All right, 7 1/3 as an improper fraction, we're going to multiply 3 times 7, we get 21, plus 1 is 22. and we keep our denominator. All right, from here, remember that this is a multiplication problem, so I want to start by canceling common factors. 2 and 22 are both divisible by 2. 2 divided by 2 is 1. 22 divided by 2 is 11. We can now multiply straight across. We get 5 times 11 is 55 over 1 times 3 is 3. We have our answer as an improper fraction, so the last thing we want to do is convert to a mixed number. So remember, we're going to use long division. 3 goes into 5 one time. 1 times 3 is 3. Subtract, we get 2. Bring down our 5. 3 goes into 25 8 times. 8 times 3 is 24. Subtract, we get 1. So 3 goes into 55 18 whole times, that's my whole number. My remainder becomes my numerator. My denominator stays the same. Now let's see here, is 18 1/3 close to 21? The answer is yes, so this is correct, or should be correct. All right, let's try a couple more. Example B. Starting with our estimate. 3 5/8, does it round up or down? 5/8 is more than half, so we're going to round that up. 4/5 is also bigger than half, so we're going to round up. And 4 times 5 is 20. All right, for our exact answer, let's go ahead and calculate this. So we get 8 times 3 is 24. Plus 5 is 29. Keep the same denominator. Times. 5 times 4 is 20. Plus 4 is 24. Over 5. All right, let's go ahead and cancel common factors. 8 and 24 are both divisible by 8. We get 1 and 3. We multiply straight across. I'm not sure what 29 times 3 is, so I'm going to go ahead and come off to the side and multiply it. We get 3 times 9 is 27. 3 times 2 is 6, plus 2 is 87. That's going to be my numerator. My denominator, I get 1 times 5 is 5. All right, let's go ahead and convert this back to a mixed number using long division. 5 goes into 8 one time. 1 times 5 is 5. Subtract, we get 3. We bring down our 7, and 5 goes into 37 7 times. 7 times 5 is 35. Subtract, we get 2. And so this is equal to 17 is our whole number. 2 is our numerator. And 5 is our denominator. We get 17 2/5. Now, is 17 2/5 in the ballpark of 20? Yes, it is. So this should be correct. All right, a couple more. Let's try 2 1/4 times 7 1/3. Starting with our estimate. 1/4 is less than 1/2. So I'm going to round down to 2. 1/3 is less than 1/2. So I'm going to round down to 7. Multiply, we get 14. All right, let's go ahead and do the exact answer. To convert to improper, we get 2 times 4 is 8, plus 1 is 9. It's my numerator. My denominator stays the same. We get 9 over 4. 7 1/3, we get 3 times 7 is 21, plus 1 is 22. Keep the denominator. All right, let's cancel common factors. We get 9 and 3 are both divisible by 3. We get 3 and 1. And 4 and 22 are both divisible by 2. We get 4 divided by 2 is 2. And 22 divided by 2 is 11. If we multiply straight across now, 3 times 11 is 33. Over 2 times 1 is 2. All right, converting that back to a mixed number. 2 goes into 3 one time. 1 times 2 is 2, and if we subtract, we get 1. 2 goes into 13 6 times. 6 times 2 is 12. Subtract, we get 1. And so this is equal to 16 is my whole number. 1 is my numerator. My denominator stays the same. We get 16 1/2. All right, one more problem for multiplication, and then we'll move on to division. Let's start with our estimate. 1/2 is at least half, so we're going to round 4 1/2 up to 5. 2/3 is bigger than 1/2, so we're going to round up to 2. We get 5 times 2 is 10. All right, let's go ahead and convert to improper. We get 2 times 4 is 8, plus 1 is 9. Keep the denominator the same, so we get 9 over 2. For the other one, we get 3 times 1 is 3, plus 2 is 5, over 3. Let's cancel common factors. 9 and 3 are both divisible by 3, so we get 1. 9 divided by 3 is 3. And if we multiply straight across, we get 3 times 5 is 15. 2 times 1 is 2. We get an improper fraction of 15 over 2. If we go ahead and convert to a mixed number, we're going to divide. 2 goes into 15 7 times. 7 times 2 is 14, and when we subtract, we get 1. So this is equal to 7 1/2. All right, so that's multiplying mixed numbers. The last thing we want to look at is dividing mixed numbers. So same thing, we're going to start with an estimate, and then we're going to find the exact answer. And again, we want to write our number as a mixed number in lowest terms if possible. Since we are dividing, sometimes these might not come out as mixed numbers, so make sure you know when to convert to a mixed number. All right, so let's start with example A. We'll start with our estimate. 3/5 is bigger than 1/2, so we're going to round up to 4. Remember, all these problems are division now. 1 and 1/2. 1/2 is 1/2 or more, so we're also going to round that up. That's going to become a 2. We get 4 divided by 2 is 2. All right, next thing we want to do is convert to improper to find our exact answer. So we get 5 times 3 is 15, plus 3 is 18 over 5, divided by 2 times 1 is 2, plus 1 is 3, from here, remember with division, we want to do our copy dot flip, so we get 18 over 5 times 2 over 3. I can cancel. 18 and 3 are both divisible by 3. We get 6 and 1. And if we multiply straight across, we get 12 over 5 times 1 is 5. Let's convert that into a mixed number. This is an improper fraction, so we do need to go one more step. 5 goes into 12 2 times. 2 times 5 is 10, and when we subtract, we get 2. So we get 2 and 2/5. Is 2 and 2/5 close to 2? The answer is yes. All right, let's look at B. Starting with our estimate. So 4 and 3/8, do we round up or down? Since 3/8 is smaller than 1/2, I'm going to round down. 5 has no fraction to it, so we're just going to leave it as 5. Now what do I do with 4 divided by 5? It doesn't divide. But what we can do is, instead of writing it as a division problem horizontally, we can write this as a fraction. 4 divided by 5 is the same thing as 4 over 5. That will be our estimate. All right, so now let's go ahead and find the exact answer. If we convert to improper, we get 8 times 4 is 32, plus 3 is 35 over 8. And I'm going to rewrite 5 as 5 over 1. All right, we copy dot flip, so we get 35 over 8 dot flip my 5 over 1 to make it 1 over 5. We can cancel. 35 and 5 are both divisible by 5, so we get 7 and 1. And if we multiply straight across, we get 7 over 8. Can I write this as a mixed number? The answer is no. This is a proper fraction, and so we are done. Do not go any further than you have to. All right, since we're done, let's go ahead and check. 7/8, is it close to 4/5? Well, both of these are somewhere between 1/2 and 1, so yes, this is going to support our estimate. All right, let's try some more. 6 1/4. If we estimate, 1/4 is smaller than 1/2, so I'm going to round down to 6. 3 1/3. 1/3 is also smaller than 1/2, so we're going to round down to 3. And if we divide, we get 6 divided by 3 is 2. All right, let's go ahead and find the exact answer. We convert to improper. 4 times 6 is 24. Plus 1 is 25 over 4. Divide by 3 times 3 is 9. Plus 1 is 10 over 3. Let's copy dot flip. We get 25 over 4 dot flip. We get 3 over 10. 25 and 10 are both divisible by 5, so we get 25 divided by 5 is 5, and 10 divided by 5 is 2. If we multiply straight across now, we get 5 times 3 is 15. 4 times 2 is 8. This is an improper fraction, so we do need to convert to a mixed number. 8 goes into 15 one time. Subtract, we get 7. And so this is equal to 1 7/8. All right, a couple more. All right, estimate 3 3/8. Does it round up or down? 3/8 is smaller than 1/2, so we're going to round down. 4 over 7. If I have 4 out of 7 pieces of candy, that means my friend has 3. Since I have more, I'm happy, so I'm going to round up. So we get 3 divided by 3. And if we go ahead and perform the computation, we get 3 divided by 3 is equal to 1. All right, let's go ahead and find the exact answer. We get 8 times 3 is 24. Plus 3 is 27 over 8. Divide by, we get 7 times 2 is 14, plus 4 is 18 over 7. All right, we can go ahead and copy dot flip. We get 27 over 8 dot 7 over 18. 27 and 18 are both divisible by 9, so we get 3 and 2. And now if we multiply straight across, we get 3 times 7 is 21. 8 times 2 is 16. This is an improper fraction, so we do need to divide. 16 goes into 21 one time. 1 times 16 is 16. And if we subtract, we get 5. So this is equal to 1 and 5 over 16. All right, a couple more. Okay, for E, let's look at our estimate. 8 has no fraction, so we're going to go ahead and leave it as an 8. 1/3, this is going to round down, so we're going to leave it as a 5. And this again does not divide evenly, so I'm going to leave this as 8 over 5. But I do want to write that as a mixed number so that we can compare. 5 goes into 8 one time. And if we subtract 8 minus 5, we get 3. So my estimate is 1 3/5. So be careful on problems like this. Don't get thrown off if your estimate is a mixed number. All right, so now let's go ahead and find our exact answer. I'm going to write 8 as a fraction as 8 over 1. If we go ahead and multiply 3 times 5, we get 15. Plus 1 is 16 over 3. All right, we copy dot flip, so we get 8 over 1 dot 3 over 16. 8 and 16 are both divisible by 8. We get 1 and 2. And if we multiply this straight across, we get 3 over 2. As a mixed number, if you know this one already, that's fine too. 2 goes into 3 one time. We multiply, we subtract, and we get this is equal to 1 1/2. Is that in the ballpark of 1 3/5? Yes, it is. All right, last one. Let's do our estimate. 1/2 is at least half, so we're going to round up. So we get 4 becomes a 5. 6 stays the same. I cannot divide 5 by 6, so I'm going to write this as a fraction. This is equal to 5 over 6. All right, let's go ahead and find the exact answer. We get 2 times 4 is 8, plus 1 is 9. We write 6 as a fraction as 6 over 1. We do our copy dot flip. We get 9 over 2 dot 1 over 6. 9 and 6 are both divisible by 3, so we get 9 divided by 3 is 3. 6 divided by 3 is 2. And if we multiply straight across, we get 3/4. As this is a proper fraction, we are done. Let's compare our answers. 3/4, is that in the ballpark of 5/6? And the answer is yes again. 3/4 is somewhere between 1/2 and 1, and so is 5 over 6. All right, that takes care of multiplying and dividing mixed numbers. It's a little technical. There's lots of steps to this, but note that this is just a combination of stuff that we've already talked about. And so for each step, just break it down into its individual components. Next thing that we're going to look at is we will be looking at some application problems, and that will finish off multiplying and dividing before we get into our adding and subtracting. So go ahead, take a break, do your homework, and then I will see you again shortly.